Hello guys, welcome back to my channel. Before we start, please don't forget to click the subscribe button and the notification button for more videos. So in this session, we're going to talk about joint and combined variations. So in the previous lessons, we are able to tackle review on ratio and proportion, direct variation, and inverse variation. Now in this section, we're going to have joint variation and combined variation. So before we proceed with our last two types of variations, let's have this activity. What is the magic formula? Instruction: match the choices in column A with the choices in column B. Write your answer on the space before the number. Alright, so all we need to do here, or our target here, is to translate the following variation statements into equation. Let's have number 1. J varies directly as L. So which among the following choices is correct? Again, J varies directly as L. So the correct answer is B, which is J is equal to KL. So this is a direct variation statement. Let's have number 2. I is inversely proportional to R. Again, it is I is inversely proportional to R. So the correct answer here is HI is equal to K over R. Next, number 3. O varies jointly to E and Y. Alright, so which among the following is the correct answer? So the correct answer is F. So when we say joint, it's also direct. F, which is O, equals KEY. Number 4, A is directly proportional to B. Alright, so this is a typical example of direct variation. So therefore, the answer is A, which is A equals KB. Next, number 5, M varies indirectly as N. This is an example of inverse variation. So therefore, the answer is C. M is equal to K over N. Next, S varies directly as L. This is an example of direct variation statement. So therefore, the answer is letter D. S is equal to KL. Next, number 7. T varies directly as R and inversely as P. This is an example of combined variation. As you can see, it's a combination of direct and inverse variations. So for number 7, the answer is, alright, so J, T is equal to KR over P. Next, let number 8, E varies jointly as X and Y. Alright, so the correct answer here is M. E is equal to KXY. Next, number 9, X varies directly to the square of A and B. So the correct answer is letter O. X is equal to K times the square of AB. Alright, so let's have the last item. 10. D varies jointly as H and E and inversely to the sum of N and G. So this is an example of combined variation because as you can see, it's a combination of joint and inverse variation. So the correct answer here is letter L. D is equal to KHE over N plus G. Alright, so in this specific activity, we're able now to translate variation statements into equation. Let's proceed. Let's have joint variation. What is a joint variation? A joint variation is direct proportionality of a variable to two or more variables. So it means that this is also direct variation, but we are talking about two or more variables. So in symbol, if Z varies jointly as X and Y, then we can say that Z, which is our dependent event or variable, is equal to KXY. So as you can see, we have two independent variables. So this is also an example of direct variation, but it became joint variation because there are two or more independent variables. Alright, so where K is the constant of proportionality or variation. So how did we know that this one is an example of joint variation? It's because of the statement varies jointly as. So that's the thing that you have to remember. Again, joint proportion or joint variation is just the same as direct variation. The only difference is that here we are talking about two or more independent variables. Alright? Let's have the first example. So in the first example, 4.1, the area of a triangle or of the triangle varies jointly as the base and the height. Write the variation equation. In the previous examples under direct and inverse variations, alright, so the first thing that I would like you to get are the variables. So in this case, we are talking about the area which varies jointly as the base and the height. So it means your independent variables are the base and height. Alright, so how did we know that this is an example of joint variation? It's because of the statement varies jointly as. Alright, so in symbol, we can now write it as the area varies jointly as the base and the height. So in equation, it is A is equal to KBH. This will be now your answer. So we can say that this one is an example of joint variation because we have two independent variables. Alright, let's proceed. As simple as that. Alright, now example 4.2. If y varies jointly as x and z, and y is equal to 6 when x is equal to 10 and z is equal to 8, find y when x is equal to 4 and z is equal to 10. So as you can see, we are looking for the value of y here. Okay, now how did we know that this one is an example of joint variation? Because of the statement varies jointly as. So what are the independent variables? We have two, x and z, and your dependent variable is y. So therefore, in symbol or in equation, this is y equals kx z. Then the next thing is we will be substituting the values for the first equation. Alright, so we will be using the value of y, which is 6, equals k, the first value of x, which is 10, and the first value of z, which is 8. So this will be your first equation. Next equation, y is unknown, so therefore y is equal to k times the value of the second x, which is 4, and the value of second z, which is 10. So that's how you are going to write your equations. Alright, next, same thing. We will be solving first for the value of k using the first equation. 6 is equal to k times 10 times 8. Then the next thing is all we need to do is to simplify. 10 times 8 is equal to 80. Next, divide both sides by 80. So this will become 1. 80 divided by 80 is 1. So therefore, the value of k is 6 over 80, or this one is 3 over, okay, so the greatest common factor is 2. So 6 divided by 2 is 3, and then 80 divided by 2 is 40. So k is equal to 6 over 80, or 3 over 40. Next, since we already have the value of k, we can now solve for the unknown value, which is the second y. Using the second equation, y is equal to k times 4 times 10. Alright, so we will be now using the value of k. So y is equal to 3 over 40 times 4 times 10. All we need to do is to multiply, then we will be getting the value of y, which is 3. This will be now your final answer. Okay, now let's have the last example under joint variation. Let's read the problem. The volume V of a right circular cylinder varies jointly as its height, age, and the square of the radius r of its circular base. If the volume of such cylinder whose height is 8 centimeters and whose radius is 3 centimeters is 72 pi cubic centimeters, what is the volume of the cylinder if the radius is 5 centimeters and the height is 12 centimeters. Alright? So, the first thing that we have to do is identify the variables that we have. So, the first variable or the dependent variable is volume. Alright? So, the first variable is volume. Next, of a right circular cylinder varies jointly. So this is an example of joint variation because of this statement. As its height, which is the one of the independent variables, and then the square of the radius, which is the other independent variable of its circular base. The next thing is we have to form our equation, which is V is equal to K times height and the square of the radius. So this will be r square. Then the next thing is we will be forming the first equation. So the first volume is 72 pi cubic centimeters equals K times the first height, which is 8 centimeters. Then the the first radius, which is 3 centimeters square. So we are going to put square because of the word square of the radius r. Next, let's have the second equation. Alright, so the unknown value here is the second volume. So therefore, we will be substituting it to V, or we will be using V to solve for the volume. In solving for the volume rather. So V is equal to K, wherein the second height h is 12 centimeters times the second radius, which is 5 centimeters square. Okay, so we can now solve for K. Alright, so always remember that we need to solve for K, or the constant, before we can actually solve for the unknown value, which is the second volume. Alright, so we will be solving K using the first equation. 72 pi is equal to K times 8 times 3. Alright, 3 square. Okay, then the next thing is 72 pi equals K times 8, wherein 3 times 3 is 9. Alright, so 8 times 9 is 72. Equals, this will be now 72 pi is equal to K times 72. Next, let us simplify. Right, so divide both sides by 72. Alright, so 72 divided by 72 is 1, and 72 divided by 72 is also 1. Therefore, K is equal to pi. Alright, so this will be now the constant. Okay, now let's have the value of the second volume. Let's solve for V. Using the second equation, V is equal to K times 12 times 5 square. Using the value of K, which is pi, let us substitute pi times 12, then 5 times 5 is 25. Then the next thing is 12 times 25 is 300 pi. Alright, so this is already your answer, 300 pi cubic centimeters, because we're talking about the volume. And the unit of the measurement for the volume here is cubic centimeters. Alright, that's what are we going to follow. Or if we will be associating the value of pi to 3.14, alright, so the answer, the other alternative answer here is, okay, so what is the answer? 300 times pi is approximately 942 cubic centimeters. Okay, so this will be now your final answer. As simple as that, class. Alright, so all you need to remember that joint variation is just the same as direct variation. The process is just the same. It's just that, okay, so we are using two or more independent events. When you are solving, the first thing that you need to do, of course, is to represent. In representing, you have to identify the variables that we are going to use and the symbol for the variables. Okay, we have to let a specific variable to be a symbol, alright, so that we can solve it easily. Then the next thing is, okay, you have to form your equations, alright. So in this case, we have the main equation, which is the equation of the variation statement, then followed by the first and the second equations, alright. Then the next thing is, that's the time that we can solve. In solving, first is solve for the constant of variation using the first equation that you have formed. And then after solving for the constant of variation, use that now to solve for the unknown value. Alright, so that's how those are the things that you need to remember in solving. Alright, then at the end, don't forget to write the unit of measurement if there is. Alright, so let's proceed. Combined variation. What is combined variation? From the word itself, combined, it means there are two variations that we're going to combine, or yes, that's the thing, that's the idea that we're going to use now. So combined proportion or combined variation, what is it? A combined variation is a combination of direct or joint variation and inverse variation. So it means we're talking about direct or joint and inverse variation. In the previous type of variation, we are only talking about joint, and joint is just similar to direct variation in a mathematical statement or equation. So therefore, in symbol, let's say z is your dependent. Z varies jointly as x and y. So as you can see, we have the statement varies jointly as x and y. We have two independent variables. And inversely as t, this is the additional variable. So as you can see, so this is an example of combined variation because of the statements varies jointly as and inversely as t. So in symbols, z is equal to kxy over t, or z varies jointly as x and y, and z is inversely proportional to t, where k is the constant of variation. As simple as that, class. So it's a combination now of joint and direct, and what do you call this? Inverse variations. Alright, let's proceed to the first example. Example 5.1. The variable a varies directly as the product of b and c and inversely as the square of d. If a is equal to 0.9, when b is equal to 0.6, c is equal to 2.7, and d is equal to 0.3, find the value of a when b is equal to 0.4, c is equal to 0.7, and d is equal to 0.2. It's quite confusing because as you can see, the values of the variables are decimals. But don't worry, this is very easy because all we need to do first is to represent by identifying the variables. Alright, so the dependent variable is a. And a varies as the product of b and c, and inversely as the square of d. So how are we going to write our main equation? So this will be now a is equal to k times the product of b and c all over, or rather over, square of d, which is d square. This is now the main equation, and this will be the basis in solving for the unknown value, which is the second value of a. Alright? Next, let's form the first equation. The first value of a is 0.9 equals k times the first value of b, which is 0.6, times the first value of c, which is 2.7, over the first value of d, which is, or square of d, which is 0.3 square. Now let's proceed to the second equation. Alright, so the unknown value here is a, so therefore this will be a equals k times the second value of b, which is 0.4, and the second value of c, which is 0.7, over, okay, the square of the second value of d, which is 0.2 square. Then the next thing is we can now solve for the value of k. Using the first equation, 0.9 equals k times 0.6 times 2.7 over 0.3 square. First thing that we have to do is to simplify. So 0.6 times 2.7 is equal to 1.62. This one is k times 1.62. over 0.3 square is equal to 0.09. So all you need to do is to multiply 0.3 times 0.3 equals 0.9. Then the next thing is cross multiply. Let us multiply 0.9 times 0.09. So you can use your calculators to easily compute. So 0.9 times 0.09 is equal to 0.081 equals k times 1.62. Alright, so to finalize the value of k, all we need to do is to divide both sides by 1.62. 1.62 divided by 1.62 is 1. Then 0.081 divided by 1.62 now is equal to 0.05, and that is the value of k. Now, since we already have the value of k, we can now solve for the value of the unknown, which is a, or the second value of a. Using the second equation, of course, which is a equals k times 0.4 times 0.7 over 0.2 square. Okay, so let us now substitute the value of k, which is 0.05. So 0.05 times 0.4 times 0.7 all over 0.2 times 0.2, which is, okay, so what is the answer? If we're going to multiply 0.2 times 0.2, it is now 0.04. Then the next thing is multiply the three variables on the numerator. So 0.05 times 0.4 times 0.7, we will be getting 0.014, bring down 0.04. Then divide 0.014 divided by 0.04 is equal to 0.35. This will be now the value of A. So therefore, this is our final answer. Okay? Simple as that. It's the same as the previous variations. What I mean the same. The steps in solving. Okay, so we're going to follow. Okay? Then the next thing is, first, you have to form your main equation or variation equation followed by the two equations that we can use or that we are going to use in solving for k and the unknown value. Now let's have the last example under combined variation. Example 5.2. The current I varies directly as the electromotive force E and inversely as the resistance R. If a current of 30 amperes flows through a system with 16 ohms resistance and electromotive force of 120 volts, find the current that a 200 volt electromotive force will send through the system. Right? So the first thing is we will be representing. Identify the three variables, the dependent, which is current. Then we have the force, and and then we have the resistance R. So the current I varies directly as the force and then inversely as the resistance. So this will be now our main equation. I is equal to KE over R. So where I is our current, E is our force, and R is our resistance. Then the next thing is we will now be forming our first equation using the first values. Then remember that we need to find the second current. Alright? Now, let's have the first one. The first value of the current is 30 amps equals K times 120 volts over 16 ohms. That's our first equation. Next, the unknown value, which is I, the second value of the current, equals K, the second value of the force, which is 200 volts over 16 ohms. So as you can see, okay, we have the same value of the resistance because according to the problem, the resistance is constant at 16 ohms. Okay, that's it. Then the next thing is we need to solve for the value of K using the first equation. 30 equals K times 120 over 16. Then next thing is we need to cross multiply. 30 times 16, we will be getting 480 equals k times 120. Then divide both sides by 120. So this will become 1. And then 480 divided by 120, it is now equal to 4. This will be the constant that we're going to use so that we can solve for the second value of the current. Let's solve for the current I. Using the second equation, I is equal to k times 200 over 16. So the unit of measurement for current is amperes. Okay, so that's the one that we're going to use for our final answer. Right? Next, substitute. K is 4 times 200 over 16. So multiply. 4 times 200 is 800 over 16. Then 800 divided by 16, the second current now will be 50 amperes. This will be now our final answer. Okay? All you need to remember is that when we are talking about combined variation, alright, so it's a combination of direct and joint and inverse variation. So that's the thing. Then don't forget the steps in solving problem or any problem. Alright, so first is identify or give the representation, equation, and then solve. So as simple as 3 steps. So these 3 steps are easy to remember. Alright? Thanks. So if you do have any questions, you can comment down so that I can answer your queries. Right? So thank you so much for being with me in this video. And then please don't forget to hit or click the subscribe button and the notification button for more videos or for more educational videos about mathematics. Right? So thank you so much and have a great day.